Okay, so what we're doing today is chapter 7.4. We're continuing on with our systems of equations and inequalities. Now what we're talking about today is partial fractions. Now you've dealt a little bit with this in Algebra 2, a little bit not so much in Algebra 1, and not in the same way. Because what we've talked about in Algebra 2 is we took two fractions like this here, 2 over x minus 3 plus negative 1 over x plus 1, and combined them and found ways to go about combining them to get x plus 7 over x squared minus x minus 6 to get this. Now what we're going to do in partial fraction decomposition is going the other way. Is we're going to start off with this here and find out what the fractions were that were added or subtracted from each other to get this. Because what it's saying is this here can be written as the sum of two fractions with first degree denominators. That is, x plus 7 over x squared minus x minus 6 is equal to 2 over x minus 3 plus negative 1 over x plus 2. We can break it down. Now we're not going to just jump through and say, okay, that's what it is, but I'm going to walk through how we do that. Now each fraction on the right side of the equation is a partial fraction, and together they make up a partial fraction decomposition of the left side, how we break it back down. Now when we start doing partial fraction decomposition, there's four main steps. So the first is we need to divide when improper. And when we're talking about improper fractions, we're talking about the degree of the numerator is greater than the degree of the denominator. So the degree of the polynomial on top is greater than the degree of the polynomial on bottom. Now whenever this happens, we have to divide or simplify it down so that we get whatever the polynomial is on top, the degree of it is less than the degree of the bottom. And we have whatever simplified out front, and that'll make more sense when we come across it. Our second main step is we need to factor the denominator completely. So completely factor the denominator into factors of the form of either of these here. Where this one here is irreducible, it won't factor. Now, you might be saying, well, we can factor it using imaginary or complex terms, and we won't use that. We won't use imaginary, complex terms, or irrational numbers, anything with a radical. So if it does not factor to whole number terms, so x plus 2, 3x minus 4, anything like that, that will work. If it factors as something like x minus the square root of 2 times x plus the square root of 2, we won't use these here. We can't have complex or irrational answers or factors with square roots or I. Those don't work. And once we get that, then we're going to break it up into the linear factors of the denominator. And again, in all of these here, the numerator is going to be one less than the degree of the denominator. So p minus x, and that'll make more sense once we get to it. And quadratic factors for each of the quadratic forms, the partial fraction decomposition must include the following sum of n factors. So if n is 3, we have to have the whole thing to the first, whole thing to the second, whole thing to the third. And this will make more sense when we start looking at them. So we're just going to go on and look at an example of this here. Now what we have is this fraction here. Now the degree of the numerator is 1, the degree of the denominator is 2, so we're good with our first step, having the degree of the numerator less than the degree of the denominator. Now our second step is to factor the denominator. So we want to factor x squared minus x minus 6. So we'll have two sets of parentheses. Now since the 6 is negative, our signs are opposite, positive and negative. The only factors of x squared are x and x. And our factors of 6 will be positive 2 and negative 3. And now we're going to break it up. Since there's only two factors on bottom, so one of these fractions will have x plus 2, and the other is going to have x minus 3. And in both of these here, we're going to put a and b. Now the lettering, you're just really going to start at a with the first one, and then just go down the line with the letters. So A, B. Now since the degree of the denominator here is 1, the degree of the numerator has to be 1 less than it, so it'll be 0. So 0, we won't have any variables. So here, because both of the degree of the denominators are both 0, we won't have any variables in the numerator. Now what we're going to do is we're going to solve for the values of a and b. Now to do that, well, I'm going to copy and paste this here and move it down so we have kind of one below it. And what we're going to do here is I'm going to multiply everything through by our greatest common denominator. And our greatest common denominator is going to be x plus 2 times x minus 3. X plus 2 times x minus 3. And x plus 2 times x minus 3. We're going to multiply through the whole thing by this. Now these here are going to cancel out completely. X plus 2 and x plus 2 cancel. And x minus 3 and x minus 3 cancel. And what that leaves us with is that x plus 7 is equal to a times x minus 3 plus b times x plus 2. And we get this here. Now, at this point here, you might be very tempted to go on and multiply these out. A times x, a times 3, b times x, b times 2. But at this point here, we're going to leave this as is. We're going to leave it like this here. And I'm going to split the page in half here. Because at this point here, x, any value of x will work for this equation. Because I could plug in any value of x and these are equal. Because again, like we said, these are equal. This side here is equal to this side here. So any value of x I plug in will work out and make it equal because these two sides of the fraction are equal. This is an equality. Now what I'm going to do is I'm going to pick a value for x over here. I'm going to pick a value of x over here. I'm going to pick two different values. Now the first value I'm going to pick is 3. And the other value I'm going to pick is negative 2. And now these values aren't picked at random. I'm not randomly picking 3 and negative 2. There's a reason for it. Now the reason I picked 3 over here is because of this right here. Because when I do 3 plus 7, I'm plugging in the value of 3 and for x is equal to a times 3 minus 3 plus b times 3 plus 2. Now the reason I picked 3 is because right here, 3 minus 3 is going to be 0. Now when we simplify 3 plus 7 is 10, then we get a times 0 plus b times 5. So by picking 3 minus 3 gave us 0, so a is going to cancel out. And what I'm left with is 10 is equal to b times 5. A is equal to b times 5. Well, b times 5 is 5b is equal to 10. So at this point here, we can divide both sides by 5. And what that tells us is the value of b is 2. The value of b is 2. And so that's helpful because what it's done now is we have found one of the values of a and b. And we found out that b, in this case here, is 2. So the value of b for this problem here is 2. And that's why we picked 3, because I picked the number 3 so that a would cancel out, leaving me with b by itself, and I can find its value. Now that's the same reason why we chose x equal to negative 2 also, because when I plug negative 2 into this here, so we'll plug it in, so I get negative 2 plus 7 is equal to a times negative 2 minus 3 plus b times negative 2 plus 2. Well, negative 2 plus 7 will give us 5 is equal to a times negative 5 plus b times 0. Again, this right here is going to cancel out completely, leave me with 5 is equal to negative 5a. And again, just like what we did with the other one, we're going to divide by negative 5 to get a by itself. And I get negative 1 is equal to a. Negative 1 is equal to A. And so by picking these two values, we found A and B. And all we have to do at this point here, so looking back at our original problem, this one here. So I'm going to use copy paste to bring it down here. We had this problem here. But this time, I'm not going to write A and B. What I'm going to put is their values, because I found that B was 2 and A is negative 1. A and B. And that's it. Now I would also keep in mind which one A is above and which one B is above. So A was above the x plus 2, so negative 1 over x plus 2. B was over x minus 3. So I plug them back in where they go. And this right here is our partial fraction decomposition. And that's all we have to do for this here. So looking at this here, when the solution is this here, now it doesn't quite have the picture in there. We broke it down to these two here, where those are our factors. Plugged in negative 2 and found B was negative 1. Here they plugged in 3 and found A was 2, and we get this here. Well, you may be thinking, looking back, well, we found A is negative 1 and B is 2. And they found B is negative 1 and A is 2. But let's look what they got. 2 over x minus 3 plus negative 1 over x plus 2. Negative 1 over x plus 2 and 2 over x minus 3. So we got the same answers. I just put it in a different order. I put it in a different order so it still matches up because our negative 1 is over x plus 2 and our 2 is over x minus 3. I know we're jumping around a bit, but that is exactly what they got here. So we got the same answer. It was just in a different order. Now we're going to look at another one. We're going to look at another example of this here. So we have x plus 5 over 2x squared minus x minus 1. Now the degree of the numerator is less than the degree of the denominator, so we're good there. So what that means is I can write this x plus 5, and we have to factor the denominator. 2 sets of parentheses. Now because the 1 is negative, our signs are going to be opposite, positive and negative. Then our factors of 2x squared are going to be 2x and x. And our factors of our constant term are going to be 1 and 1. 2x times negative 1 will give us negative 2x, plus x gives us negative x. So this works. And again, you can check it to make sure and work it out, but these are going to be our two factors. Equal. So now we can set up our partial fraction decomposition. Since I have two sets of factors on bottom, 1, 2, and they're not to any power, so I'm only going to have two fractions, one for this one and one for this one here. 2x plus 1, x minus 1. A, B. The degree of both of these fractions, or the denominators of both of these fractions, are still 1. So we're not going to have any variables in the top. We'll eventually get to one where we will, but at this point here, we just have a over x plus 1 plus b over x minus 1. Now again, I'm going to use copy paste to kind of bring this down here so we can work with it. All right. I'm going to extend the page out just a little bit so we have room to work. So I have room to work. Now what we're going to do first is we're going to multiply through by our greatest common denominator. So that's going to be 2x plus 1 times x minus 1. 2x plus 1 times x minus 1. 2x plus 1 times x minus 1. And when we multiply through by this here, these here will cancel out with these here. 2x plus 1 and 2x plus 1. X minus 1 and x minus 1. So what that leaves us with is x plus 5 is equal to a times 2x plus, not 2x plus 1, it'd be just x minus 1. Fix that. X minus 1 plus b times 2x plus 1. And we have this here. Now we can go about checking for two values of x. Now here we're only going to need two values of x because I only have a and b. I'm only solving for two letters. Now one of the values for x is going to be 1 because that's the value that's going to make this one here 0. Now the value of x that's going to make 2x plus 1 0 might be a little bit harder to see, so we can go on and set it up. 2x plus 1 is equal to 0. We can subtract 1 from both sides, giving us 2x equals negative 1. Then we're going to divide both sides by 2. So x is equal to negative 1/2. So negative 1/2. So we went through this process to find out what value of x would make this 0. And now that we have this, I'm going to erase it. So if you're still writing that down, go on and pause the video and write it down. But I'm going to erase this here for space. And move that back up here. Because these here are two values of x that are going to make us have a 0 somewhere. Either when we plug in 1, we'll solve for b. When we plug in negative 1/2, we're solving for a. Because negative 1/2 will make this part 0. 1 will make this part 0. So if I plug in 1, I get 1 plus 5 is equal to a times 1 minus 1 plus b times 2 times 1 plus 1. Now we're going to go on and solve this out here. 1 plus 5 is 6 is equal to a times 0 plus b times 2 plus 1. Well, a times 0 is just 0. It's gone. So we get 6 is equal to b times 3. So 6 is equal to 3b. And at this point here, we can divide both sides by 3, telling us that b is equal to 2. So we have the first variable, or one of our two letters, solved for. We solved for the value b. Now we're going to solve for a. So I'm going to plug negative 1/2 in. Plus 5 is equal to a times negative 1/2 minus 1 plus b times 2 times negative 1/2 plus 1. Well, negative 1/2 plus 5. We could plug this into a calculator. So we'd have 5, or negative 1/2 plus 5. And if we plug that in, we would get 9/2. Now I'm going to write it as a improper fraction, a little bit easier to work with. Now negative 1/2 minus 1 is going to be negative 3/2 plus b. Well, 2 times negative 1/2 is going to be negative 1 plus 1. So here we get 9/2 is equal to negative 3/2 a plus b times 0. Well, that's just gone. That's 0, so that cancels out. Now I'm just going to go on and erase it because it is 0. It's gone. Gone. And what we have is this here. Now at this point here, there's two different ways we can solve for a. One of them is we can divide both sides by negative 3/2, or we could multiply both sides by negative 2/3. It doesn't matter which one we do. So if we divide both sides by negative 3/2, on our right side we're going to get a. On our left side, we will get negative 3. So the value of a is negative 3. Our value of b is 2. So when we plug these back in, we're going to be plugging in for a and b. So a, in our case, this a value here is going to be negative 3. So instead of writing a, I'm going to write negative 3. And instead of b, we're going to write 2. So this right here is our answer. Negative 3 over 2x plus 1 plus 2 over x minus 1 is the fraction decomposition, the partial fraction decomposition for this problem here. So the homework assignment for 7.41 is going to be on page 508. You're going to be doing problems 9 through 12 and 17 through 21. Now 9 through 12, you're just writing the partial fraction decomposition in terms of a, b, and x. So you're not actually solving for the values of a and b, you're just splitting it up. 17 through 21, you're going to go on and split it up and solve. And you don't have to check your answer for this here. You just need to at least get the partial fraction decomposition.